Welcome to the Engineering Update. I'm Associate Editor Jamie Wisniewski. In this week's episode, Raspberry Pi's long-awaited touchscreen display, biodegradable components scrap e-waste issues, and a hedgehog in space. The Raspberry Pi is an awesome low-cost developer board that is an incredibly easy way for people to explore computing and programming. It's capable of doing everything you'd expect a desktop computer to do, from browsing the internet and playing high-definition video to making spreadsheets and playing games. But one of the things many Raspberry Pi fans have been waiting for is a display that's made specifically to support Raspberry Pi projects. Well, now that wait is over. People who want to give their Pi touchscreen capabilities now have the option to transform the mini computer into a tablet, thanks to a new 7-inch touch display that's on sale for just $60. The new display isn't exactly iPad Air quality, although for just $60 you really can't complain. It features a resolution of 800 by 480 pixels that can display video at 60 frames per second in 24-bit color. The Raspberry Pi display supports DSI and DPI integrations and has a bridge chip conversion board to convert between the two supported integration methods. The touchscreen uses capacitive technology and has 70-degree viewing angles. The display is metal-backed and has mounting holes for the Pi hardware. Of course, once you buy this display for your Raspberry Pi, you'll have to assemble it. To do this, you'll have to plug the display's conversion board into the Pi's display connector, and you'll also need to find a way to power the display, which can be done via a separate power source of at least 500 milliamps or with a USB link or general-purpose input-output jumpers. Raspberry Pi has listed the full instructions on their website, so go ahead and check them out and start building.
According to the United Nations Environment Program, electronic waste, also known as e-waste, is the fastest growing waste stream in the world. In an effort to cut down on this, researchers from the Young Investigator Network at KIT in Germany are developing printed electronics from natural and compostable materials that could help make a dent in the millions of tons of electronic waste piling up worldwide each year. Heavy metals, silicon, and other elements stick around for a while and can even potentially create harmful and toxic hazards as they begin to break down in landfills. Instead, the team is working with biodegradable materials, including semiconductors and dyes made of plant extracts and insulators fashioned out of gelatin. Once the electronics are no longer needed, the components can be thrown in with biowaste or compost, where they will rot like any other organic material that decomposes. Researchers are working with carrier foils made from natural materials like starches and cellulose, and even hard gelatins like those used to make drug capsules, which can be good for insulation. The next key part the researchers need to focus on before manufacturing is the development of inks for printing circuits that have all the required environmental and conductive properties. They're aiming to have the electronics ready for suppliers in about 3 years.
Designing components and technology to explore space is really challenging. It's a very harsh environment, and as an added bonus, the terrain is difficult and the surprises unlimited. While it's difficult to design vehicles for larger things in space like Mars, it's an entirely different challenge to design for smaller bodies like asteroids or comets. On these small bodies, low gravity conditions and rough surfaces throw additional issues at engineers. The newest challenger to these tough issues is the Hedgehog, a robot designed specifically for these challenges that are specific to small bodies in space. The project, being conducted by NASA's Jet Propulsion Laboratory, Stanford University, and MIT, is focused on designing a robot that's able to tumble around a bit instead of the more traditional rolling movement seen in other space robots. The cube-shaped robot is able to operate no matter which side it lands on after it tumbles and hops to the desired location. 8 spikes on the outside of the cube protect it from the rough terrain, and 3 internal flywheels allow the robot to continue its odd movement. The hopping movement is used for long distances, while the tumble technique allows Hedgehog to move forward shorter distances. It can also do a tornado movement, in which aggressive spinning allows the robot to launch itself off the surface. That movement will be reserved for situations where the robot is really stuck. It weighs about 11 pounds without instruments, which could bring the total weight up to about 20 pounds. The researchers are hoping that in the future, several of the robots could be attached together and taken to space by a mothership. They could be released individually or all at once to explore space. As an added bonus, it's not a very expensive robot to make, particularly when compared to more traditional space robots. Hedgehog is currently in Phase 2 development. That's all for this week's video. Be sure to check in on Twitter and Facebook and watch past episodes at ecnmag.com. For the ECN channel, I'm Casey Panetta, and this has been your Engineering Update.
You know, isn't like a little parched?
I went from rocking to flapping. I don't know which one's better.
So ain't Casey smash. All right.